let's go ahead and begin. I think this first part of the problem is really pretty straightforward. I don't know that I would ask these questions the same way on a test this year, and I'll tell you exactly why. So in this problem, I have what looks to be a clear collision where the bullet's going to pass through the first block. So as it is a collision, we would be able to say that the momentum of the system before, so if I add up the momentum of the bullet, momentum of the block before, that has to equal the momentum of the bullet and the block after. So all I'm going to do is plug in all the information I need to calculate momentum, which is mass times velocity. So what is the speed of the block after the bullet emerges from the block? Well, I don't know that, but I do know that the bullet has a mass of 0.1 kilograms and is traveling at 500 meters per second, while the block has a mass of 1 kilogram and is not moving. So that must be the momentum of the system before the collision. Questions about that? Excellent. So after the collision, I assume the block is moving. That little arrow next to it, pretty big assumption. But more importantly, the bullet has less velocity now, suggesting that its change in momentum was given to the block. So I expect the block had a change in momentum, unless the block was fixed in place or clamped to the table, and there's nothing to say that it was. So this looks like 50 equals V plus 10. So V must equal 40 meters per second. Okay.
The 100 meters per second, wasn't that with the block? That was 1 kilogram?
No, I think it's the bullet.
It says passes.
The bullet strikes and passes through a 1 kilogram block initially at rest, emerging at a speed of 100 meters per second. So if you made the block travel at 100 meters per second, your answer is going to be more divergent. But I believe that it's referring to this. Oops. I didn't mean to do that. I don't know what I did, and it won't go back. So I don't know what to do now. Well, it's just going to have to be like that because I can't fix it, and I don't feel like working that hard at it. Okay, maybe Mr. Shelton is going to figure this out. Unlikely. I'm figuring something out. Yay. Fine, whatever. No, and I believe the velocity of the block is going to be 40 meters per second. Any questions about that? All righty. What is the impulse experienced by the bullet due to the collision with the block? Impulse is change in momentum, and we're asked specifically about the bullet. I will point out that as this is a collision, the bullet and block experience the same impulse. They're just opposite. Newton's third law. So I want you to tuck that away because that's a great question for multiple choice. Nice little trick question, stuff like that. So it's going to come up, I'm sure, on tomorrow's test. So just be aware the bullet and the block have to experience the same impulse unless there's an outside force acting on the system. So they want the bullet. So that's going to be the change in momentum. And that will be final minus initial. I haven't said it, but I'm making this way positive. That's kind of obvious if you're paying attention, but maybe not if you're not really seeing it. I made all the velocities positive, and all the velocities appear to be to the right. Tomorrow, you understand, look for those little differences. So as I move forward with this question, I'm going to have, let's see, 0.1 times 100. That is the final momentum, minus 0.1 times 500. That is the initial momentum. And that looks to be 10 minus 50, or negative 40 kilograms meters per second. Units are going to be a significant part of tomorrow's test. I would imagine that if you don't have the units correct, you're not going to be able to get full credit. All right. If instead the bullet gets stuck inside the block, what will be the velocity of the bullet block system? Now, you don't have to redo the entire problem. We know the momentum before isn't any different. So all the stuff on the left side is the same. What has changed is the stuff on the right side. The block has a mass of 1 kilogram and a bullet 0.1, and they have the same combined velocity. So divide my 50 by 1.1, I get what, 45 meters per second? Something close to that. So before I answer the last question, I think there's something missing that I would ask this year. So if you're wanting to know how tomorrow's test will be different than today's test, some of the things that I would encourage you to be able to do is calculate the change in kinetic energy. That's something I would expect. Does that make sense? Because I talked about it in class. When this test was given out, it was given out before we covered energy. So there's no energy questions on here, but we've done this after energy. I would expect energy questions to be a part of your test tomorrow. All right, moving on. I think your explanation here has to say three things. And this test, when I gave this test the first time, which has been like 3 years or 2 years ago, I wasn't as focused on the writing portion of the test as I am today. So I'm expecting your writing to be better, and I'm expecting to have more of it on the test. I don't think this test really brings that portion out. But remember, you have to connect all the dots. And although I am clearly steering you towards some of the things, some of the topics that should be here, you should be able to say in a clear written prose what's happening. So it says, consider the difference in the two collisions explained in the paragraph. By passing through the block, produce a different velocity for the block than when the bullet gets stuck in the block. The first thing I think you should talk about here is impulse of the bullet. I think that's something that is clear. The impulse of the bullet is greater when it is stuck in the block than when it passes through. It had a greater change in velocity and therefore a greater change in momentum. So I think the first thing should be discussed is impulse of bullet. And you should be talking in that by addressing the change in momentum and the change in velocity. You have to explain why the impulse is different between the two. And that is completely tied up in the fact that the velocity was different. The second part, I think probably Newton's third law. A greater change in momentum of the bullet means a greater change in momentum of the block. You have to connect the change from the bullet to the change in the block. And then you probably should state again, a larger impulse on the block means a greater increase in its velocity. So change in momentum to impulse of the block. I think you have to say all three of these things. I think you have to connect all the dots. Basically, you have to explain how a change in the bullet results in a change in the block. And you have to list, I think, the things that are associated with that change. Does that make sense? Any questions about that? All right. So, sorry to anybody actually watching this. I didn't record any of that. So, that's okay. The answers are there. So you can follow along with the answers. But you can fill them all in on what I said about that. That I wouldn't do A and B back to back on the same test on multiple choice. All right, so 13.95 kilograms meters per second. Made a big deal about writing units down. It's a weird unit. I would make sure you know your units. Yep.
So I just switched the direction. Like the initial was positive and the final was negative, so I got 13.95, but it's negative.
That's fine. That's fine. I don't indicate direction in this problem, so as long as you're consistent, you're fine. I'm not good at doing this next part, but if I were writing tests for AP Physics for College Board, one of the ways they get around that is by adding the word magnitude to the problem. What is the magnitude of the impulse? Which means it won't matter whether your answer is positive or negative. As long as you have 13.95, it'll be there. The magnitude means I just want the size of the answer. I still get the same distractor because people who have not done this will have a different answer, and I'm still able to put that as a distractor as well. So magnitude still tests the capability without throwing students off for positive or negative. But students don't often remember the word magnitude and its meaning. And remember, the word magnitude just means size. So if they ask for the size of the answer, they're asking for the scalar part of the answer. Just plug that in here to figure out the force. And it's probably pretty big. So when you get that force, it is in newtons. Make sure you get the units right. Question C is a lie. I would not put question C on the test now because it's a lie, but it does what I wanted it to do. But for those of you who are into baseball and softball, I am not. Hitting a slower ball will not result in a faster return. So this produces an inaccurate result. And the reason isn't because of anything that's necessarily wrong, except that I'm indicating it would be the same impulse. But a ball that's thrown slower likely will be in contact with the bat for less time, and therefore won't have as large an impulse imparted to it. So when we find out that the answer is actually faster, that's not true. So you want to swing, if you're in baseball, you want to swing for the fastballs. So anyways, well, you want to swing for whatever gets you a hit, I assume. I don't know. I don't play baseball, but I have baseball players in the room. But you get a faster return when you hit a fastball than a slow ball. This will be different, though. It's telling you to take this 13.595 and do m v final minus m v initial. This will suggest the ball will be hit faster, but it won't be. It won't be. All right, last. Players who want to hit the ball faster but don't want to get stronger can cheat, but getting the ball to stay in contact with the bat, by getting the ball to stay in contact with the bat longer, I think I was supposed to say by getting the ball to stay in contact with the bat longer. They hollow out the bat, fill with cork, a softer wood. Explain why this would be effective. This is effective. Manipulating the time of contact is effective at causing a larger change in momentum. If you can make the ball stay on the bat for a longer period of time, then you will get a larger impulse. That's first thing that needs to be said. The second thing is that a larger impulse means a larger change in velocity. That's the second thing that needs to be said. I think a third point to be made is that there should be something about the force not changing, but the time increasing. If they swing with the same force stays the same, time increases. Increase in time means an increase in impulse. Increase in impulse means an increase in the change in momentum and therefore the change in velocity. I think this is 3 points. So something about force and time increasing, that means an increase in change in momentum, and that an increase in change in momentum equals an increase in change in velocity. But you will have to write that in sentences, not archaic symbols with arrows. Saying a larger impulse will make the ball go faster skips all the middle pieces and won't get you credit. I think that just saying that would probably be 1 point, because you don't say why the impulse is greater, and you don't say how a larger impulse leads to a larger velocity. So remember, the idea is connecting the very first topic, change in time, to the last topic, change in velocity. All right. We have had a discussion of conservation of energy at this point. And we've also had discussions now of conservation of momentum. So I see no reason not to have a problem that asks about both. I see a bullet strike a block. Let's say that the bullet becomes embedded in the block. And the block and the bullet go up to some level on an incline. And say the maximum height that they make it to is 1.25 meters above the ground. If the block has a mass of 0.5 kilograms and the bullet has a mass of 0.05 kilograms, what is the velocity of the bullet before the collision? I think this is a very reasonable question. I would probably ask this in parts, but I think you should be able to do this problem without me breaking it down to parts. But if you don't have a feel for what's happening here, would you agree that the bullet and block will have a velocity after the collision? Would you agree then that because the bullet and block have a velocity after the collision, they have kinetic energy after the collision? And if the block has kinetic energy and it starts going up a ramp, do you believe it'll convert that kinetic energy to potential energy? I think you should be able to do this. I think it's a two-step process. I think you need to figure out how fast the block and bullet were going after the collision. I think you have to do that first from conservation of energy. And then run a collision question. Try it. See if you can do this problem. In the interest of time, what kind of energy do we have here? So mgh. What kind of energy do we have here? Kinetic, so 1/2 mv squared. In this part, the mass doesn't matter, actually. You'll notice that, I hope. So we find that the velocity is going to be equal to the square root of 2gh. So square root of 2 times 10 times 1.2. I don't know what that is, but it's probably a little bit more than 4 and less than 5. Yeah. Okay. So 4.9 meters per second. I would keep a couple decimal places between steps. That's a good way to go. Now, this is the velocity of the bullet block system after the collision. So there is a collision where the bullet by itself had some velocity and the block had none. And after the collision, the bullet block system had a velocity of 4.9 meters per second. I see this as a fine question, and there's not a whole lot to it, but I think that students tend to forget first semester. Well, we can't. Have you ever heard the phrase variation on a theme? If not, here's variation on a theme. The theme is still conservation of momentum as it pertains to other types of problems. Look familiar? We've done projectile motion problems. If I tell you where something lands, can you tell me how fast it was going when it left the table? And if you can figure out how fast it was going when it left the table, you should be able to figure out how fast the bullet was going before it struck the block. To me, again, similar question. Do you remember your projectile motion stuff? So you're shaking your head, but that doesn't change the fact that it was taught. You may want to review it. I am supposed to be able to call upon any of the things you guys have had in class. And your tests are cumulative and always have been. Yep.
What is the 0.05?
The mass of the bullet. So, I would start with your little chart, with a horizontal and vertical. I'd look and say that, well, the y velocity here is going to be 0, but it falls a distance of negative 1.4 meters with an acceleration of negative 10 meters per second squared. Can I use that to figure out how long it's in the air? Yes, I can. And I know that the range is 1.5 meters, and I want Vx because Vx is how fast it's going after the collision. Again, variations on a theme, meaning there's collision here, sure, but a collision triggers our projectile motion problem. This is how they're going to do this on the exam. Very seldom is a collision problem the entire scope of the problem. Most times a collision problem is a part of a larger problem. I mean,